Lesson 3 is on something called the sine law. And this may sound familiar because you've used sine, cosine, and tangent before, but this is a little bit different. Okay, it's the same button on your calculator, but it's not exactly the same relationship. So we're adding another tool to your arsenal for solving triangles. This one is specifically for triangles that do not have a 90-degree angle in them. Okay, it works for all triangles. It works for 90-degree triangles, but it's easier to use SOHCAHTOA for 90-degree triangles, and so you would really only ever choose to use this if you really love it in all circumstances, or if you are working with a non-90-degree triangle. Okay, this relationship works anyway. So let's look at this triangle that we have down here. We have everything filled in. So it's not that we're trying to solve for anything, but I'm showing you how the sine law works, okay? So we've got angle A is 80 degrees, angle B is 60 degrees, angle C is 40 degrees, given all those things, and then we're given all these sides as well. Now we're going to name the sides because that's important for the sine law. The convention is that in a triangle with its corners named as such, the sides are named with the corner that's opposite them. Okay, so this 7.11 centimeter side, that's side A, side little a. So the big A is the angle, the little a across from it is the side that's across from it. Across from it. Did I say across from it enough? Angle B is 60 degrees, that makes 6.25 side B, little b, and 4.64 centimeters is little c. Okay, the sine law has everything to do with opposite pairs. So angle A and side A, that makes what I will call a side angle pair. C and C, that makes a side angle pair. Little b and big B make a side angle pair. Okay, they're always going to go together. Now, what the sine law says is that the ratio between the angle, the sine of the angle, and its matching side is always going to be the same no matter which pair you pick. So if you take side A and divide it by sine of angle A, you'll get the same number as doing the same thing with B or doing the same thing with C. So let's give that a shot. Angle A is 80 degrees, and so we've got that filled in here. Side A is 7.11 centimeters. So if we do 7.11 divided by the sine of 80 degrees, I'm going to do that on my calculator so you can see what it looks like typed in. So this is my calculator. Backwards, wasn't that thrilling? 7.11 divided by the sine of 80 degrees. That's how mine gets typed in. Your calculator might want you to type it in 7.11 divided by 80 sine if you have a one-line calculator, or if you're using your phone, shame on you. 7.11 divided by the sine of 80 degrees is equal to 7.2197. Okay? B, we're going to do the same thing. So angle B is 60 degrees. Side B is 6.25 centimeters. And when we go 6.25 divided by the sine of 60 degrees, you get 7.2169. C, same thing. 4.64 is side C divided by sine of 40 degrees. When you do that division, you get 7.2186. Okay? Now, the only reason why they are not exactly the same instead of just pretty much the same is because the numbers that we're using over here are all slightly rounded numbers. You would find that you get even closer if you use a whole bunch more decimal places. Okay, but we don't want to make it all that painful. We just want to show that when you take a side and divide it by its angle pair, the sine of its angle pair, you get the same thing no matter which side angle pair you pick. Okay, in this case, we would say that we get 7.22 no matter which pair you pick. We're going to do the same thing for one more triangle, except this is called P, Q, and R. There's another example here, but I'm going to leave you to do that one on your own, just to get used to how your calculator wants things typed in. And you can check that you're doing it right if you get 3 answers that are pretty much the same. I'll let you do that now. Since those ratios are always the same, that leads us to a formula. The formula is called the sine law. And if you look on the left at the top over here, you get what we would call the sine law. A divided by sine A is equal to B divided by sine B. That's also equal to C divided by sine C. So what it's really saying is that if you take any pair, any side angle pair, the ratio is always going to be the same if you do it like that. And it also doesn't actually matter if you do it upside down or right side up. So notice that if we flip those upside down like this, and you do the sine of the angle on the top and you do the side on the bottom, it still works exactly the same. Okay, so you'll never really actually use all 3 at once. This whole thing is not really an equation that you're going to use. It has 2 equal signs in it. How do you type that into your calculator? You can't. So you would really only ever use a pair of them at once. You do one side angle pair is equal to another side angle pair, never all 3 at once. So let's do a couple examples here. We're going to find a side length. Now my advice to you is that when you're using the sine law, whatever you are looking for, whether it's a side or an angle, put that thing on the top of your ratio. Okay, so we're looking for a side length here, or we're looking for 2 side lengths. We would call this side A, and we would call this side B, right? Because this is angle B, and across from angle B is side B, and this is angle A, and across from angle A is side A. So we can figure out really anything that we need to in this triangle because we know a completed side angle pair. Okay, I want you to look at this. This 32 degrees over here is angle C. This 12 centimeters is side C. And what you're looking for to figure out if you can use the sine law or not is, do I know a completed side angle pair? And we do in this case. We know the side angle pair C and angle C. Okay, and so we're going to use that as part of our sine law equation. The other thing we're going to do is do side B first, because we have half of that pair. Okay, so I'm looking at angle B over here. That's 72 degrees, and I just don't know what side B is. Okay, so I'm going to set up the sine law. C over sine C is equal to B over sine B. Now, I said you should put the thing that you're looking for on the top. And the thing that I'm looking for is side B over here. And so I want to use the version of the sine law that has the sides on top. That'll just make the algebra easier later on. Okay, so now I'm going to fill in the numbers that I know. I know that side C is 12 centimeters. And I know that angle C is 32 degrees, so that's the sine of 32 degrees, is equal to, B is what I'm looking for, I can't fill it in, but angle B I do know, it is sine of 72 degrees. Okay, now we did an algebra step some time ago when you were learning trigonometry, and this has happened before. When you are looking for this piece, the top of a fraction, I have a divided by 72 that's attached to it. See that? To get rid of that divided by 72, because I want to get that b by itself, I multiply by 72. Well, not 72. I multiply by the sine of 72 degrees. Okay? That's getting rid of this divided by sine 72 on this side. And what I do to one side, I have to do to the other side. So here's what I end up with. 12 centimeters divided by the sine of 32 degrees, and I'm going to multiply that by the sine of 72 degrees. And that equals side B, right? Because I took my divided by sine 72 and I multiplied by sine 72. And so these things are now canceled off of that side. And what I'm left with is just the sine 72 on this side. And a B by itself on the right side. So now I'm going to put this into my calculator. 12 divided by the sine of 32 degrees times the sine of 72 degrees. And when I calculate that out, I get 21.54 centimeters. Okay, put that into your calculator, check that you can actually get that answer. If you didn't get 21.54, then we need to figure out how your calculator wants you to type this in. Now, we also can figure out what angle A and side A are. Okay, let me just point this out. We know two angles. Do you remember what the three angles in a triangle have to add up to? It's 180 degrees, right? So in order to figure out what angle A is, we just need to go 180 minus 72 degrees minus 32 degrees. And that will give us what we're missing. Okay, but we're going to get into that a little bit later. I just wanted to show you, first of all, how to solve for a missing side. I wanted to also say that this algebra step that we did over here, there are many ways of doing this. So some of you might have learned the fish method, like this. You take sine 72 times 12 divided by the sine 32 equals B. Okay, it ends up being exactly the same thing we just did. It's just a quick trick to remember what the algebra step is. Now let me give you an example of solving for an angle. So we are told just this 83 degree angle over here. And we are supposed to find one of the other two. Okay, so we could find all of them if we wanted to, but we're not going to for this example. We'll save that for the next one. And so I want to ask myself, as always, do I see any completed side angle pairs? So this is angle A, this is side A, this is angle B, this is side B, angle C, side C. So I can see that this side angle pair is completed. I have both the side and the angle. So I'm going to use that one to start off with. Okay, I'm trying to find an angle, and so I'm going to put the angles on top. That's just for me. If you're using the fish method, it doesn't really matter which way you do it. But it's good. It's a good practice to put the thing you're looking for on top. So I'm going to find angle C because I know side C. If I look at the B stuff, I don't know side B or angle B. And so since I know nothing about the B pair, I'm going to leave that for later. And in fact, I'm not even going to do it for this one. So I'm looking for angle C. So I'm going to put the angles on top. Sine C over side C is equal to, and my other pair that I'm using is the A pair. So that's sine A over A. Okay, now I'm going to put in my numbers. So sine C, which I do not know, divided by 15 centimeters is equal to sine of 83 degrees divided by 25 centimeters. So when I'm solving for sine C, I want to get rid of this divided by 15 here that's attached to it. And so I'm going to multiply by the other side by 15. Right? So in order to get rid of the divided by 15, I multiply by 15, and I do the same thing to the other side. And so I end up with sine 83 degrees divided by 25 times 15. Now, if you enjoy the fish method, it goes like this. 15 times the sine of 83 divided by 25 equals sine C. Okay, so it works the same way. You're going to end up doing the same thing no matter which method you use. So I want to do the sine of angle C is equal to sine 83 degrees divided by 25 times 15. And when I do that, I get 0.5955. Now that might seem confusing at first if you don't remember how this sine, cosine, tangent thing works, because this angle over here, it does not look like 0.5955 degrees to me. It looks a lot bigger than that. And you'd be right, that's not our final answer. This equation here says the sine of angle C is 0.5955. Okay, that doesn't say that angle C is 0.5955 degrees. I have to undo this sine over here. So my last step is doing the inverse sine, undoing that sine of 0.5955. And when I do that, I'm going to get angle C. This little L-shaped thing, it denotes angle. And so when I do that, then I get something that makes more sense, 36.55 degrees. And that's the end. So there's one extra step when you're looking for an angle. That's that very last step over here where you have to do the inverse sine in order to get your angle. And the last thing that we're going to do here is show you the procedure for solving a whole triangle. And what we mean by solve a whole triangle, or solve this triangle, is fill in all the missing pieces. So in this case, we are missing angle B and angle A. We are also missing side B. And that's it. 3 things we're going to be missing. And it's always going to be 3 things. Okay, so I want to first of all, as always, look for completed side angle pairs. Do I have anything completely filled in? And I can see that angle C and side C, those are completely filled in. So the other piece of information I have is this 35 centimeters, and that is side A. And so since I have half of this A pair, that's the other part that I'm going to be going for. I'm going to be looking for angle A. Okay, so because I'm looking for an angle, I'm going to put the angles on top. So sine of angle A divided by side A is equal to sine of C over side C. Put in my numbers. I do not know angle A, but I do know that side A is 35 centimeters. I know that angle C is 60 degrees, and I know that side C is 50 centimeters. So now I'm going to do my algebra, which is multiplying by 35. And so sine A, when I do sine 60 divided by 50 times 35, gets me 0.606, etc. And so then I need to do the inverse sine of 0.606, etc. And that gets me 37.32 degrees. So that's angle A now. That's 37.32 degrees. That's my first piece out of 3 filled in. My second piece that I'm going to fill in is the last angle. Because I know that the 3 angles have to add up to 180 degrees, I can solve for my last angle by subtracting the other 2 from 180. And so angle B is equal to 180 degrees minus that 60 degrees, that's angle C, minus that 37.32, that is angle A. And so angle B is equal to 82.68 degrees. So now we have angle B as well, 82.68. So our final step is solving for side B. And so I'm going to set up the sine law for side B by putting side B on the top over sine B is equal to, and then honestly I can choose whichever pair I want. I can choose the C pair because it's completed, or the A pair. But because I have rounded the A numbers, or I have rounded the A angle, I may as well choose my C pair because it's completely unrounded. It was a set of numbers I was given at the beginning. And so C over sine C is what I'm going to use for that one. So I've got B over the sine of 82.68 degrees is equal to 50 centimeters over sine 60. And so I'm going to do sine of 82.68 times 50 divided by the sine of 60. And so my final piece here, side B, is 57.26 centimeters. So it seems like it's going to be a lot of work to do all three of them. Once you start out at this first spot over here and you solve for that first angle. But the other two steps go pretty quickly after that because you can fill in the other angle just by doing the 180 minus thing. And then your last step is figuring out that missing side. And then you're finished.